Question 14a, Part 1. Sketch the graph of y equals x cos x for x greater than or equal to negative pi and less than or equal to pi, and hence explain why the integral from x equals negative pi over 2 to pi over 2 of x cos x dx equals 0. Let y equal x cos x. X-intercepts occur at x equals 0 and x equals plus or minus pi over 2, since these are the x values where either the x term or the cos x term in the product equals 0. Now x cos x is greater than 0 in the interval 0, pi over 2, and x cos x is less than 0 in the interval negative pi over 2, 0. Geometrically, the graph of y equals x cos x is an odd function, hence has point symmetry about the origin, and this needs to be shown in the graph. Here is the graph of y equals x cos x. It may help to do a table of values to get a little bit of extra detail in the graph. So it's important to show that it is an odd function and the three x-intercepts are shown. Now the integral from x equals negative pi over 2 to x equals pi over 2 of x cos x dx equals 0 because the function is odd and signed area is being considered. Now note, as a general rule, the product of an odd function and an even function is odd. Part 2. Consider the volume of the solid of revolution produced by rotating about the x-axis the shaded region between the graph of y equals x minus cos x, the x-axis, and the lines x equals negative pi over 2 and x equals pi over 2. Using the results of Part 1, or otherwise, find the volume of the solid. Since the volume of the solid of revolution is produced by rotating the curve about the x-axis, the formula for the volume is given by v equals pi times the integral of y squared dx, which equals pi times the integral from x equals negative pi over 2 to x equals pi over 2 of x minus cos x all squared dx. Expanding the brackets, we get pi times the integral of x squared minus 2x cos x plus cos squared x dx, which equals pi times the integral of x squared plus cos squared x dx, since the integral from x equals negative pi over 2 to x equals pi over 2 of x cos x dx equals 0 from Part 1. And this equals pi times the integral from x equals negative pi over 2 to x equals pi over 2 of x squared plus half times cos 2x plus 1 dx. Which equals pi times x cubed over 3 plus 1 over 4 times sine 2x plus x over 2 from x equals negative pi over 2 to x equals pi over 2. Applying the limits of integration, that equals pi times pi cubed over 24 plus 1/4 sine pi plus pi over 4 minus negative pi cubed over 24 plus 1/4 sine negative pi minus pi over 4. Which simplifies to pi times pi cubed over 12 plus pi over 2. And factorising out 1 over 12, we get pi over 12 times pi cubed plus 6 pi cubic units.